There we go. Okay, so Avogadro's principle says that equal volumes of gases at the same temperature and pressure contain equal numbers of moles of gas. The molar volume for a gas is the volume that 1 mole occupies at 0 degrees Celsius, which is 273 Kelvin, and 1 atm of pressure. That's known as the standard temperature and pressure, so STP. Any 1 mole of gas will occupy a volume of 22.4 liters. It doesn't matter what the identity of the gas is, that's irrelevant. Any 1 mole is going to equal 22.4 liters. So our conversion factor is 1 mole equals 22.4 liters. In order for this conversion factor to work, that has to be at STP. Next week, we will go through situations where we use this, where we're not at STP, and I'll show you how to deal with that then. Stoichiometry comes back next week. That's your BCA tables.
Oh. The ones that we came in were like
Avogadro's law then. I don't think I spelled his name right. Avogadro's law. There we go. Is V1 over N1. N is moles. Equals V2 over N2. And that's when your temp and pressure are held the same. Yeah.
What is that word? It there's an arrow pointing to that.
Moles. N is the kind of universal abbreviation for moles because mass is M. So they had to figure out something else, and well, that's the next letter, so why not use that? All right, so pretty easy today. We've got grams of carbon dioxide given, or that we want to find out. We're given that we have 1 liter of CO2. So we're going to use our new conversion factor, which is here. We're going to put liters on bottom and moles on top. For every 1 mole, we have 22.4 liters. Then we want to take our moles and go into grams. So for every 1 mole, we have 44.0 grams. And I got the 44 from carbon dioxide. Remember, carbon dioxide is CO2. So that's going to be 12 for your carbon. 2 oxygens are 32. So if you add that together, that's your 44. And that's your molar mass for CO2. Okay, so see if you can get that calculation on your calculator.
My dad's like, so you drop this calculator and really know you use it. Babe, I didn't know how to use it when I first started. Yeah. I couldn't figure out how to type it. I was like, how do I even type this? I was about ready to type in 3.14, so. She looks at the number 5. 3.14, 159. I got 1.9642 5 7 months. Got me saying this. Oh, wow. What did you get, Julia? 1.964. Okay.
All right, so this guy ends up being 1.96, and that's going to be what unit? Grams, because our moles will have canceled, our liters canceled, and that leaves us with grams of CO2. Okay, next one. Here, this should be H2 with a lowercase 2, sorry. We have 0.00992, that's an ugly 2 grams of H2. We want to convert our grams into moles. Then we want to convert our moles into liters. And then finally, our liters into milliliters. So see if you can get the numbers put in here the right way. Okay, figured that out.
Derek told me the other day that I could have the solar theory.
How'd you do? Did you get the right answer?
I got 11. I got 111.1. I got 11.11. Oh, babe, you did something wrong. It was not that.
Aiden.
I did not get that.
Oh, I did times 100 instead of 1,000. My bad. Uh-oh.
0.00. Oh, 0.0. Oh, there's why I did wrong. Okay, 0.00992 times 22.4 times 1,000 divided by 2. Now, how about 111?
There we go. That sounds fine.
Okay, sorry. I dropped a 9 on there. All right, we fixed it. Surprise, Lippy did something wrong. It's the lead in the gas. That's what it is. It's the lead in the gas. Yep, that's what it was.
Yeah, I relate to that.
Okay, so 0.416 grams of kryptonite. See if you can get that into, let's go liters. Yep. Yes, like your initials.
You said liters?
Liters.
Okay. How do I get these numbers? Yes, you do. Oh, this is the molar mass. Yeah.
All right, so krypton.
No, don't do it yet. No. I haven't really heard anything except for the chart. Yeah, dimensional house. So putting the grounds and some more.
83.8. 1 mole. 1 mole. 22.4. See if I can come up with the right answer this time. I ended up with 0.111. That would be liters. Convert that into milliliters, it would be 111 again. All right. Any questions on those three? All right. Next one then, we have volume of the container. We've got 2.4 moles of gas. Does it matter what the gas is? No, it's irrelevant. Identity of the gas doesn't matter for this principle to hold true. So here I'm going to have my 1 mole and my 22.4 liters. So it ends up being 53.76. And that's going to be liters. Okay. This should be a lowercase 2. Sorry about that. What size container do you need to hold this guy? So see, we've got 0.0459. That's moles. Does it matter if it's in 2 or not? No, it doesn't matter at all. So this is going to be 1 mole and 22.4. So I ended up with 1.03 here. And the next one, you have 1.02. Go moles into liters. And that ends up being 22.8. Easy enough? All right, so homework tonight is your 13-2. Today your lab is due, the one that looked like this. Okay, so that's due, so make sure that you get that turned in. Last day that will be accepted is the 5th. If you need me to look it over before you turn it in, come up and bring it up to me and let me look at it, okay? And that is it for today.